Okay. One thing I wanted to do was try to help you out a little bit with graphing. I think there's definitely some dilemmas. To start off, if I just said, look at that graph right there, could you tell me where quadrant 1 is? I'm hoping that you all agree it's there. 1, 2, 3, 4. If I said, where is the y-axis? Hopefully you realize it's there, and the x being there, right? If I said, where's the origin? If I said, what quadrant would 5, comma, negative 2 be in? You ready? Okay, does that make sense? So hopefully the basics are with you and you're fine. If you remember that ordered pairs come in the form xy, we should be fine again. So if I said, hey, where's 3, comma, 11? You'd say, well, up 3, up, and it'd be good, right? If I said negative 4, negative 8, you'd say right about there, right? I think that's right. Okay, that makes sense. So, good. One of the things that is oftentimes trickier than it should be is just graphing some nice little ones. What if I said x equals 2? And I said, where does that get graphed? Well, it's a vertical line. It goes on forever and ever at x equals 2. Whenever x is 2, there's a line there. That's all there is to it. What if I said y equals negative 4? Well, when y equals something, it's horizontal. X can be 1, 2, 3, 4 to infinity, but y is always equal to negative 4. Okay? So that's one good thing about that, I guess. Let's try something else. What if I said y equals mx plus b? This is kind of the most common form that you guys have seen for years. You just, you don't do it every day. I get that. You forget. But b is equal to your y-intercept. Okay? And m is equal to your m value, or your slope. And slope is defined or described as rise over run. Okay? So if I had something like y equals 2/3 x plus 1, and I said graph that. Well, the first thing I'm going to do is look at that b value. That 1 is where I put a dot right on the y-axis. Okay, start at 1. Then it says, let's rise up 2 and over 3. Remember, rise over your run? Now, obviously, when you go up, it's positive. When you go down, it's negative. And just like running, when you go to the right, well, I don't mean real running, but when you're running on a number line, to the right is positive, to the left is negative. Okay? So if I started there at 1, like I already said we did, right? And from there I went up 2 units and over 3. 2 units over 3. And I connected that line. Okay, does that make sense? I hope. That's really all there is to that. Let's say we get rid of that and we do something else. What if I said, can you graph y equals negative 3/5 x plus 6? Okay? So I'll wait for a second. You think if you have it or not. Good. So we look at 6 right there. And I'd put a little dot at 6, right? And then I'd go down 3 units and then over. Does that make sense? So you'd start at 6, down 3 over 5, and you have something that looks like that. Okay? Okay. What if we had something in standard form? Okay. Now if I had something like ax plus by equals c, that's kind of like a linear equation, or it is. It just looks a little different than you're familiar with, okay? And I can even prove it real quick, not that you're probably dying to know, but if I subtracted ax from both sides, then don't I have b times y is equal to negative ax plus c? Okay? And if I divide both sides by b, don't I have y equals negative a over bx plus c over b? And that's in the same form as, that's my m or my slope, and my y-intercept is c over b. Okay? So we're going to use that way of thinking in just a minute. I'll show you a little trick if you forgot it. Okay? What if we had just a few rules? ax plus by equals c. And I'm going to tell you that my x-intercept, where I hit the x-axis, is equal to c over a. I'm going to tell you that the y-intercept, where I hit the y-axis, is equal to c divided by b. And there's a reason this does this. Let's say you want your x-intercept. Wouldn't you set your y to 0? Well, if my y is 0, isn't 0 times b gone? Yes, it is, right? And if I want my x, it would just be c divided by a, and vice versa. When I want my y-intercept, wouldn't my x be 0? And then I divide both sides by b, and that's my y-intercept. Okay, so what this gives you is a real easy way to graph when you have standard form type stuff. Okay, what if you had 2x plus 3y equals 6? And I said, can you graph that using those little tricks? And you'd say, yes, yes I can. So if I said take c divided by a, 6 over 2, I think we'd agree that that'd give us oh, sorry, I missed that. Give me 1 second. Maybe a little bit neater here. Here we go. Sorry. So we'd say 6 over 2 gives us 3, right? And then I'd say, well, where's my y-intercept? And I'd say, well, my y-intercept, isn't that c divided by b? C divided by b. So when I do that out, give me 1 second, and I said c divided by b, I get a 2. Okay? Ooh, that's a fancy color. And when I connect those, I would be done. Again, 6 divided by 2 is 3. 6 divided by 3 is 2. And we're done. So hopefully this helps you graph two forms of a linear equation in y equals mx plus b form and standard form. And I think that's it. Let me add one more thing while I'm here. Give me 1 second. One other thing that seems to come up some is just what would happen if we had, I don't know, a 5, 2 and a 6, 7. And I said, let's calculate the slope. Now, obviously, you could plot those points. You could put a dot at 5, 2 and a point at 6, 7, and count the rise over run, meaning you could make like a little triangle. Okay? You can always do that. That's completely fine. What would be good, though, is if we understood this concept right here. Give me 1 second. So I'm going to give you a rule. y2 minus y1 over x2 minus x1 is equal your slope. Okay? So when I want my slope between those 2 points, I'm even going to label these for you real quick. What if I said that is x1, y1? Just use my first x and my first y. And let's say that is x2, and that is y2. Okay? So I'm going to follow this rule here. y2 minus y1 looks like 7 take away 2. And that gives me a 5. And then we do my x's. 6 take away 5 gives me a 1. So my slope would be defined in rise over run as 5 over 1. And if I look at it real quick, couldn't I just rise up 5 and run 1? That's kind of what I was talking about, a little triangle, right? Do you see how that works? And that's just another way to find it. Okay? Hopefully that helps. If you get stuck, just let me know. Okay? Good job.